Hey guys, it's Miss Hageman. This video is going to take you through slides 1 through 7 of our Heights Right Triangle Trig Desmos activity. This is an introduction to trigonometry. There are many objectives covered in this Desmos, so there will be other videos to follow. So today we're going to look at the Pythagorean theorem, which you should recognize to find a missing side of a right triangle. And we're also going to look at whether 3 side lengths of a triangle form a right triangle. And then tomorrow and next week, we're going to go through the other objectives about exactly what trigonometry is and how those ratios are set up. Slide 2, how are you feeling today? You can use this slider to let us know that it was a good day, it was an average day, it wasn't a good day. And if you want, you can tell us more about how it's been going for you. If not, make sure you just pick a picture. So slide 3 is a review. So you want to recall what a ratio is and how that is connected to proportions. So a ratio is a comparison of 2 values, and we express that as a quotient, which is division or a fraction. So a class has 12 girls and 18 boys. The ratio of girls to boys is 12/18. You could also reduce that to be 2/3. The ratio can be expressed as a fraction if you don't say 12/18. So 2/3 would be another way to write that ratio. Now a proportion is comparing those two ratios with an equal sign. Okay, and we did ratios and proportions when we looked at our last chapter, chapter 8 on similarity, where we looked at sides of triangles to decide if those triangles were similar or not. So we are going to use ratios in this next chapter for trigonometry. Slide 4, we know things about angles of triangles. So the angles of a triangle always add up to a certain number. We want you to explore a little bit by moving these points and try to make these angles not add up to this number. There is no way to get these angles to measure anything other than a certain number. It's also called the triangle sum theorem. Okay, so I'm going to make mine a little bit easier with calculations. I'm going to make one 100 degrees, and then we'll get the other one so we can add in our head a little easier here. So we'll do 100 and 40 and almost there. There we go. So this is 100 plus 40 is 140 plus another 40 is 180. And so what I just drew for you here is an obtuse, okay, isosceles triangle because we have the two 40s. So angles of a triangle always add up to 180. Now, the topic that we're covering, if you look back at the objectives, we have Pythagorean theorem, right triangle, sides of a right triangle, trig ratios for a right triangle, using right triangle trig. So a right triangle, we're going to change our 100 degrees to 90 degrees. And so we are specifically going to look at triangles that add up to 180, where we always have one right angle. Okay? And so there's not a box here, but we do want to have that be 90 degrees. And then I do want to point out that the other two angles, no matter if they're 40 and 50, 45 and 45, let's keep that back at 90 here. Sorry about that. So these two other angles, these are called complementary angles. So angle C, which is 47 degrees, is complementary to angle B, which is 43 degrees. Complementary means adds up to 90. Slide 5. We know things about the lengths of sides of triangles using something called the Pythagorean theorem. Okay, so we showed you this back in first semester, first quarter, in the beginning of the year when we did basics of geometry. So the Pythagorean theorem says a squared plus b squared equals c squared. This is always going to work as long as your a and your b are plugged in correctly and you know what your c is. So a and b can be switched. It doesn't matter if a is, in this case, the 3, or if you say b was 3. I like to go in order of number, so I would make a 3 and b 4. So a and b are always the legs of the triangle. Those can be switched in and out for each other. But C always has to be the hypotenuse, which is across from the right angle. And it's always the biggest number because this diagonal is larger than the other two numbers, okay? This does have something to do with slope, where 4 could be a rise and 3 could be a run. So you can use Pythagorean theorem to find the distance of a segment, which we did earlier in the year as well. Okay, there is a table down here. If you zoom in, you can see something called Pythagorean triples. Pythagorean triples are shortcuts, so you don't have to do the work. So the first Pythagorean triple is a 3, 4, 5. The 5 is the C, so that means every time you do 3 squared plus 4 squared, you'll always get 5 squared, which is 25. And then you can also do multiples of those. So there is a 6, 8, 10 triangle. Again, it's just a shortcut for the Pythagorean theorem. And you can go all the way up to 7 squared plus 24 squared equals 25 squared here at the bottom. Okay. So let's actually do the work. So I want to show you these calculators. So we have a keyboard calculator here, which is a math typewriter. We also have one up here at the top, the scientific calculator. You want to use these. You don't want to use Google. You don't want to use your cell phone because these calculators are very similar to the one that you'll see on the state test. And if you use these calculators in Desmos, I can see your answer and I can help you out if you're stuck. Okay, so find the missing length of the triangle to the left. So we know that 3 and 4 are A and B. Okay, so we want to type in A squared plus B squared. So 3 squared is going to be your button to the left where it says A squared plus 4, and hit that A squared again. A is just any, it stands for any number that could be squared. And that is going to give you 25. Now don't type 25 here. That's not our answer, okay? That is C squared, okay? We still have to do another step because the triple tells us it should be 5. 3 squared plus 4 squared is 5 squared. So we want to hit enter with our keyboard, and then we want to do the square root of 25. So the Pythagorean theorem is 2 steps. You're going to add up your squares. 3 squared is 9, 4 squared is 16, which is 25. And then you always want to do the square root. So our answer is 5. I'll show you another way to get 5 with this keyboard down here. You can also type the square root first, and then type the 3 squared plus 4 squared underneath it. So let me show you that as well. So I'm going to open this keyboard here. Again, this scientific calculator to the right was from clicking the top of Desmos. So let's open this one. So another way to do this, might be quicker for some of you, is to hit the square root first. And then hit 3 to the second power plus, and always make sure that square root bar is getting longer. 4 to the second power. Everything has to be underneath it. If it's not, then you're going to get a different number other than 5. Right? So the missing length of the triangle is 5. Slide 6, we want you to notice that it's a little different from the other one. Okay? In this case, I'll redraw the triangle. You can do that as well. Or if you understand what I'm talking about, you don't need to. Okay, just so we can label our A, B, and our C. So 12 is actually our hypotenuse. It is not A or B because we have our 90. And so we're going across from that. Okay. So 12 is going to be our C. And then 8 is one of the legs. So that can be A or B. In the last case, we made that bottom number A, so we'll just stay consistent there. And so we'll call this A. And it appears like B is a little higher or longer than A is. So sometimes some of you might want to go in order of smallest to medium to largest. So C is 12, A is 8. And so we're looking for B here. And so X is going to be what we're trying to solve. And that actually is going to be our side that we're going to call B. So again, A squared plus B squared equals C squared. Now when we know what C is, we're not going to add. We're going to do the inverse operation of addition, or the partner operation to addition, which is subtraction, to give us a smaller number. Because we're taking our C, our 12 squared, and we want to subtract the 8 squared to get a smaller number, okay? And that'll give us an answer that we're then going to need to take the square root of, okay? So C is the longest, A and B are the legs. We're going to subtract those. And then once we get our answer, we have to do the square root of that. So that sketch pad should help you see what we're going to type in the calculator. And in this case, this is a text box, so we can type it in here. We can also use this calculator here as well, which will give us the answer. This math type is only going to be able to type it in. It's not going to calculate it for us. So we'll use the calculator at the top. Just like we did on the last one, we'll do the shortcut where we type the square root first. And so square root, and we're just going to follow the sketch pad. We're going to do the C squared first and subtract the 8 squared so then we can get the smaller number. So 12 to the second power plus, again, make sure that your square root bar, oops, Miss Hageman made a mistake, minus 8 squared. And don't round that to 9. I'll show you why in a minute. So 12 squared minus 8 squared is 8.94. Now, if you want to see those separate, okay, 12 squared is 144. 8 squared is 64. And so if you add those both up, you will get 208. And so the square root of 208 is 8.94. I can type it in correctly. Nope, it's minus. There I go again. We're subtracting 80. The square root of 80, I knew it was too high, is 8.94. So that's how they got that, by just typing that all in. Now, the reason we don't round up to 9 is because the square root of 81 is 9. 80 and 81 are different numbers. So it's not exactly 81. It's not exactly 9. The square root of 80 is going to be our answer, 8.94. So don't round too far. We want to round to the nearest hundredth in this case. All right, so we have our work here. I'm going to type that in. So I'm going to do the math. I'm going to do the keyboard. I'm just going to type in the square root of 12 to the second power minus, fix my mistake there, 8 to the second power. And so that is going to equal, actually, we don't want that to continue. So let me click outside the box and then hit equals on my keyboard. 8.94. So that's our answer for x. So x equals 8.94. And it's approximate. We rounded. Make sure you don't round to 9 because 9 times 9 is 81. So that's an example where we're using subtraction. We're using the Pythagorean theorem still, but we're not adding, we're subtracting to get a smaller number. And then our last slide, determine whether the angle is a right triangle, yes or no. So we need to order our numbers in terms of small, medium, and large. So if you're not sure what 2 times the square root of 30 is, go ahead and just type it in the calculator. And that's 10.95. So that's our middle number. So that's going to be an A or a B. So 14 is going to be our C. Okay. So A is going to be 9. B is going to be 2 times the square root of 30. Keep it to, let's see if we can do it here. There we go. I'm going to have to write this one. It's hard to type when it's not the math typewriter. So C is 14 because that's the largest. And I'm going to have to write B is going to be 2 times the square root of 30. And these are hard to type in because we don't have the square root bar on the calculator, I'm sorry, on the keyboard here. It's going to write it in. So it's going to be 2 square root 30. And so what we're going to do is we're going to square these, and we're going to see if we get c squared. Okay, so we're going to square all these numbers and see if it's a true equation. If it is, then it's going to be a right triangle. It's going to be yes. If it's not a true equation, then we're going to select no. It's not a right triangle. The angle is going to be off a little bit. So this is a yes or no. Okay, and we want to decide that based on, do we have an equation here when we square these? So A is 9, smallest, B is 2 times the square root of 30, and C is 14. And we're going to use this calculator here. And so we have 2 times the square root of 30 in here. What we can do is we can actually put parentheses around this. So if you go to the beginning, you can open a parenthesis. If you go to the end, you can close the parenthesis, and you have to square all of this. If you just hit the squared after the 30, it's not going to square everything. So that's 120. Okay, and we know 9 squared is 81. So we have 81 for a squared, and b squared is 120. And then we want to look at, if we're adding these together, okay, is that going to give us c squared? And so 14 to the second power is 196. And again, we're not sure about this, so we need to add 81 plus 120. And we can see here that 81 plus 120 is not 196. That's actually 201. So 201 is not equal to 196. So this is not a right triangle. You would have to get the same number on both sides. So select no for slide 7. And that concludes the first video for these heights right triangle trig notes.